This video is on depth of knowledge. Depth of knowledge is one of the most useful tools when designing questions to enhance student learning and to enhance student performance for a particular concept. It relates to how much information of a concept students are required to incorporate when they are answering a question, and students that incorporate more information of a certain concept when they are practicing it. So in other words, if they are practicing the concept at a deeper level, it enhances their memory of that concept and it allows them to remember it for a longer period of time. So without further ado, I will introduce what depth of knowledge is if you have not yet encountered it. The goal of this video is to inform you what depth of knowledge is at an entry level and to give you enough examples so that you can be confident either creating or at least in recognizing depth of knowledge questions. You've probably heard of Bloom's taxonomy. Bloom's taxonomy is a hierarchy for level of thinking that students engage in when they are answering a question. Bloom's taxonomy is level 1 is just basic knowledge. Level 2 is comprehension. 3 is application. Then it goes analysis, synthesis, and evaluation. Some models of Bloom's taxonomy do flip synthesis to be on top and evaluation to be the 5th step. But Bloom's taxonomy is a hierarchy for thinking. It does not relate to the actual level of knowledge for a field of content. So I'll give a quick example. Logic puzzles tend to be a higher order of thinking. 4 or 5 analysis, evaluation, perhaps synthesis, depending on how it's written. But it doesn't require a lot of concept or conceptual understanding or domain knowledge. I've myself made a lesson where students have to use a logic puzzle to identify solutions and unknown mixtures, where students have to use logic to identify a series of or a set of unknown solutions. Just on that, the logic puzzle to identify unknown solutions, that uses a higher order level of thinking. But if all they're required to know then is to match solutions with their appropriate place, so solution 1 is, sodium chloride solution. Solution 2, magnesium chloride. If that's all they're doing, they're thinking at a high level, but they're not really using a lot of chemistry. My teaching program, at my university, I learned about Bloom's taxonomy. I didn't encounter Webb's depth of knowledge until actually one of the schools I taught at was emphasizing it. And then I did some additional research on my own. It's been around for about 20, 25 years. However, it is far more effective in developing curriculum and in getting students to relate their knowledge while thinking at a higher order. So let's take a quick look at what those 3 levels are. We'll also look at examples. So here are the 3 levels of depth of knowledge. Now, the involvement of knowledge increases here on the y-axis going up, and the actual DoK level is here on the x-axis. And so depth of knowledge level 1 is basic recall. This is where students are essentially just pulling out a label or pulling out a basic fact or piece of information and assigning it when they're asked a question. What is a proton? What is the charge of a proton? What subatomic particle has a charge of +1? These are all basic questions that require students to just pull one label out or one small piece of information out as recall. Level 2 is explanation. Why do protons have a positive charge? Now that will require understanding of quarks, but why does helium have an atomic mass of 4 AMU? Why does lithium have an atomic mass of 7 AMU? What role do neutrons play in the nucleus of an atom? They don't have a charge. Why are they there? All right, those are DoK level 2 questions because they require students to have some level of understanding. They require students to explain a certain phenomenon. That's level 2. And finally, we've got level 3, which is strategic thinking. What would happen if the electrons in an atom have the same mass as a proton and neutron? What would happen to an atom if there were no neutrons? So that's depth of knowledge level 3. First of all, questions at all 3 levels are important. DoK level 1 questions are great for covering a lot of information. So you can't cover a lot of information when we're thinking at DoK level 3, but DoK level 1 allows us to cover the most information. So DoK level 1 questions are effective at their job, basic recall. Now, the things that we want students to understand a little bit deeper, or the things that we really want students to remember, is going to be DoK level 2. Most of the questions that I write are DoK level 2. The reason is because it's the optimum of involvement of knowledge and time needed to complete the DoK. As DoK levels increase, the amount of time needed to spend to get to that DoK also increases. And so to understand something, to be able to explain it, isn't quite the same amount of time needed to think strategically about it. So the example I gave earlier of electrons being the same mass as protons really also requires a lot of understanding about particle mechanics, which isn't something we explicitly cover. And so there's going to be extra steps we need to get there to equip students to think at a DoK level 3. So this does have its uses, but primarily DoK level 2 questions are a huge sweet spot for our science teachers because it does require students to think at a higher order, but it doesn't require them to tie a whole lot of different information together, which the level 3 or the strategic thinking often requires students to do. Helium has 4 EMU. What's helium's atomic mass? 4 EMU. Okay, well, I can say that, but I don't need to really understand or tie meaning to it. But if I say helium has 2 protons and 2 neutrons in the nucleus, and each proton and each neutron has a EMU, or atomic mass, of 1, those 4 particles give helium its atomic mass of 4. Now what we've done is we've assigned meaning to that question, and that's going to not only help students understand it at a deeper level, it's going to allow them to remember it for a substantially longer period of time. You've possibly taught for multiple years, and you probably have topics that you get to where students just, they never seem to remember it. Polyatomics is a good example. I can't remember if phosphate is -2 or -3. One possible reason for that is because they're looking at it as a list. Phosphate is -3, carbonate -2, nitrate -1. And they're not tying meaning to it. They're memorizing it. And things that we remember in this fashion, our brains aren't designed to remember it for long periods of time. One of them is to teach it at a higher DoK, and that's going to embed it deeper in the students' brains, and it's going to allow them to recall it for a longer period of time throughout the year. The second thing we can do, which I'm not advising you do this all the time, but it does have its moments, is repetition. So students will probably forget the polyatomics if they look at it for 1 or 2 or maybe even 3 days. But if you have them look at that list and use that knowledge, even at a DoK level 1 for 2 or possibly 3 weeks, they're so much more likely to remember that for the duration of the semester, if not the year. There's something called the Ebbinghaus curve of forgetfulness, which basically, that's not what this video is talking about, but the more repetitions that a student has of a certain fact or piece of knowledge, the more likely they are to remember it for a longer period of time. And the other factor is we want to space those exposures out. We want to space those exposures out over a longer period of time as well. So seeing the polyatomic 7 times in the same day isn't going to be nearly as effective as seeing them 7 times over the next 2 weeks. Or 10 times over the next 2 weeks. So we've covered DoK level 1, DoK level 2. Why DoK level 3? Well, it turns out this really does depend on your educational philosophy. But for me, what really resonates with me is building real scientists or building students who can think scientifically in the real world. DoK level 1 and DoK level 2 don't really do that. This is more about giving students knowledge. DoK level 3 is more about getting students to use the knowledge they have to think strategically and solve real-world problems. The example I gave earlier of what would happen if a electron had the same mass of a proton, well, they'd really have to crank that gear and think, okay, well, it's just normally really small, it's moving about. It's really big. Well, its momentum is going to be, maybe it's going to carry it off. Maybe it's going to collide. Maybe the force that prevents the electron from entering the nucleus won't be strong enough if the electron has that much mass. And so we see that the thought processes that kids have at this higher order really is about integrating fields of different information and manipulating that information to solve a problem. And that's what scientific thinking is. When kids, if they get a job at one of these big companies or if they end up working in a lab anywhere, it's really the strategic level of thinking that leads to advancement and development. And so this is absolutely something we should be building in our students. And so it really comes down to where and when can we integrate DoK level 3. So thank you, teachers. Thank you for your interest. It is awesome that you are learning. We are students every day, and that's what makes us good teachers. Good teachers are good students. So thank you for watching, and I'll see you again shortly. Bye.